Now, just like with circles, you have to do examples which require completing the square. We all hated completing the square in whatever, year 9, year 10, whenever you learned it, because you're like, I can just do the formula, I could just factorize, it's so much simpler, okay? But completing the square remains useful, actually, for questions like this, okay? So let's have a go at, let's do this one. So here is the equation of an ellipse. Our job is to find all of these guys. We're going to find all of the features. Center, foci, directrices. Okay? So being that these are what we want to find, you can read them off if you can get it into this form. Yes? So how do we twist and turn this? What are you going to do? Okay, so the first thing we want to do is do a bit of sort of combining stuff, yeah? So for instance, you have 4x squared and your 24x there. 4x squared, 24x there. X's together, good. You've got your 9y squared and your minus 36y there, y's together. What should we do with this constant? I should kick it over this side, okay? Even though it's minus 36, it should get fixed up when we complete the square. And besides, we want all of the constants on this side anyway. Okay? All right, what am I going to do to this? I can't complete the square just yet. What do I need to do? Completing the square, at least the method we've learned, only works on monic quadratics. Okay, where the leading coefficient, this guy and this guy, where they are just 1. That's what monic means. Yeah. So I'm going to need to do some factorizing here first. I'm going to have to do it twice. Once for the x's and once for the y's. So far so good? Okay, now I can complete the square. I've got to add 2 numbers. What do I add here? What is completing the square? You take that coefficient there, right? You do 2 things to it. You halve it and you square it. Halve it, then square it. So halving it gives you 3, squaring it gives you 9. Okay, now, don't forget, since I have a 4 at the front there, okay, you're actually not adding 9 to both sides. You're actually adding 36. Beginner's error. Okay, people see the plus 9 and then they add 9 over here and they wonder why their ellipse isn't an ellipse, okay? So in fact, I'm going to add numbers. As I complete the square, I'm going to do it to both sides at once. So I have minus 36 and I'm going to add 36, okay? Let's just do it the other one. Plus 9, y squared minus 4y. What do I add? 4. Which means again I added 36. So I'll do it again. Okay. Now what? I can do 2 things really at once, can't I? If you feel uncomfortable, you can do this in 2 steps. I'm going to factorize, and at the same time I'm going to divide. Okay? If you want to break that apart into 2 lines, that's fine. Okay? What do you get here? That's x plus 3. Divided by 9. This will be y minus 2 divided by 4. See what I've done? That 36 is going to become the one that we're after. Okay? Excellent. So there was the first kind of major hurdle we got over. We've gotten it into this form. So now, how do I get from that form to all of this rubbish? Well, I can do HK. That's nice and easy because h and k are in the equation that I formed. So the center, I can already read it off. It is minus 3, 2. Okay, great. But to get the foci and the directrices, I'm missing a piece. What piece am I missing? I'm missing the eccentricity, okay? So which important thing did we use to find the eccentricity of something like this? What's the, okay, b squared equals a squared 1 minus, good, okay. We have our a squared and our b squared, they're right there, okay? So let's stick them in, shall we? What do I got here? 4 equals 9 squared. squared. Does that all check out? Look happy? So now what? Now what? Take the square root. Okay, so we're more or less there. Do we need to finish it off, or do you guys reckon you could do the monkey work?
We can do the monkey work.
Okay, see if you can keep up with me. If I can do it faster than you on a whiteboard, that's a bit embarrassing. H equals 3, A is equal to 3 as well. Okay, so therefore, my foci should be at 3 plus or minus 3 times root 5 on 3, comma, k. Whoops, minus 3. That's better. Okay, so that's equal to, let's see, cancel, cancel, plus or minus, it's going to be minus plus, it doesn't matter. 3 root 5, comma, 2. Did I do something wrong? Yeah? No? What happened? Where?
At the front of it.
Here?
You didn't add it on down one.
Here? Oh, right. Yeah, what have I done? Sorry. That should be there. That's what I meant. That's better. Okay, directrices, they're actually kind of simpler, to be honest. You don't have to worry about the y coordinates. So h equals minus 3 plus or minus a, which I said was 3, all divided by 9. So that's minus 3 plus or minus, that 3 goes on the top. That look right?
Are we allowed to write it that's just plus minus?
You mean like that?
Yeah.
Rather than saying 2 equations? Yeah. Okay, right. You want to be safe, yeah? So if I were you, at the end, shouldn't say or, should say alternatively, okay? What you want to write is plus or minus means x equals, I generally write the negative one first because it's to the left. So minus 9 on root 5, or x equals minus 3 plus 9 on root 5. And I guess the same goes here.
But can we like name it in a sentence?
Say it again.
Can we like therefore like dot dot dot?
Yeah.
And then directrix x equals 2 equations.
Yeah, that's fine. That's fine. It all answers the same. Let me finish this off. You've got minus 3 minus root 5, or 3 minus 3 plus root 5. Okay, so you're done.